Welcome back, everyone. Hope you had a great break. I'm super excited to have a great set of panelists here to talk about what is most important for our organization at this time. We're going to talk about the Open Spatial Computing Platform. And let me introduce our eminent guests. We have Christine Perey. She's calling herself SPIME Wrangler. Can you explain what is a SPIME Wrangler?
It's a role that was defined by Bruce Sterling some 15 or more years ago as someone who manages the intersection of space and time.
Great, perfect. So Christine, she sits on OpenAir Cloud's governing board. She's also co-chair of the OGC Standards Working Group on GeoPosts. And she is the brains behind the Open Air Cloud framework, and she will speak about that soon. Also from the OGC Standards Working Group on GeoPosts, we have Steve Smyth. He has a really great background in the intersection between geospatial and computer graphics. And he's also a central figure within OGC, co-chairing and chairing several working groups, and has a long background in standards work. Also with us, we have James Jackson. He is OpenAir Cloud's CTO. He is leading the design and development efforts for our Open Spatial Computing Platform. And he has really amazing technological diversity and does everything from machine learning to complex network systems and open source geospatial systems. Then we have Vladimir Ufnarovskii. He is a co-founder of Augmented City. And he did that amazing thing that he committed to being the organizer of the very first testbed, city-scale testbed for the Open Spatial Computing Platform. We're going to hear more about that later. We got Mikko Karvonen from Finland, from Immersal. He is chief. Hello, everyone. So he's chief product officer at Immersal. And he was actually the first one who committed to supporting the GeoPost standard from their AR Cloud technology platform. Lastly, the man of the future, Jason Fox. He is your director of R&D and spatial computing in Worlds.io. He was previously a chair or co-chair in one of our most important working groups. He was at the stage with me at the Augmented World Expo right after our first symposium. He's in his line of work, he's tackling the most important challenge regarding to encoding the physical world in machine readable form. So that is not in our first test beds, but he will speak to what we can expect later on in test beds. So let's start with Christine. You were the editor of a chapter in our State of the AR Cloud report, where you outlined the Open AR Cloud framework. Would you say a few words about that?
Sure, thank you, Jan-Erik. Yes, I think it's a conceptual framework I want to emphasize. And at the core of this framework is an practically infinite amount of information, the digital world, not just the digital world that's been mapped to the physical world, but all data, linked data on the web and elsewhere. So this is really central to our concept, and that's what brings to life AR experiences. So around this core is are some services. As you heard mentioned already, there'll be a reality capture service to bring that reality into the digital world. And then we have to map and understand that, the position, the orientation. The spatial mapping is tightly coupled with GeoPose. And then we will have a phase where we're enriching this data, combining with the spatial map and the data, and combining it in a way that is semantic, that has world understanding. So it has context and relationships embedded in this framework. And then finally, a very important service that's the ability to continuously search on all those data using context as the query for the search. So in the place of entering speech or text or an image to query a data set, we're going to be seeing that the user's environment, the user's physical environment, and the settings that they have in their software will be the basis for continuous querying. Then the results of that can be brought to this presentation system and combined with the physical world. So it's a highly conceptual layers with these 4 services: reality capture, spatial mapping and geopose, contextual and semantic tagging, and finally this, building on all of those, the contextual search.
Great. So that is our future vision. And a part of that vision is also that this is not just a concept. We want this to develop into standards, and there are some missing standards. And one of the key standards that we need for this platform concept is geopose, and we have been very lucky to be a close partner of the Open Geospatial Consortium. Previously on this symposium, you heard Scott Simmons speak in more general terms about the work of OGC, but now we have a really key member of OGC who is very central to the work on the standards working group on geopose. So, Steve Smyth, can you explain a little bit about how are we actually making standards in OGC? How do we do that?
Thank you, Jan-Erik. The overview really is that we're going from ideas to an OGC standard. And my role, I think, is in part to be an OGC guide. I'm a person who's gone through the process of going from ideas to standards in OGC 3 or 4 times. And so I think what I'll do is I'll start with saying that we think of the use cases, in other words, how geopose can be used, how it works in AR, how it works in other related fields, is the starting point. And we, from that, work out what the core concepts are. And one of the challenges of standards work is to produce a result that actually accomplishes the goal, which is to make one way to do some useful task and publish that so that implementers can use it. One of the challenges is going from a lot of different ideas via a consensus process. In other words, people generally have to agree that what we're doing, what we're deciding something means, a word or structure, is what's intended. This tension between many ideas and a simple, concise standard is really the challenge of the development process. So we start with what we think are the important use cases. We take them apart to understand what are the working pieces, the concepts, and really here we're still working in words and natural language in English in the case of OGC. And writing at a point where we have a conceptual landscape which is big enough to include the thing that we're trying to standardize. Once we've done that, then we can crystallize parts of that conceptual landscape as logical data models or interfaces for an API. In our case, in GeoPose, we're just dealing with data objects, little chunks of data that describe where something is and a direction, a location, and an orientation. And in going through this process, once we've arrived at a logical model, then we need to think about what specifically are we going to standardize? What are the things that show up in the document that an implementer actually can depend on or must obey in order to produce something that conforms? So part of what OGC does is, through the standards program, define this process of going from ideas, concepts, a logical model, implementation targets or requirements to produce a document which is a standard that is testable. And OGC provides a framework where if you're an implementer or if you're a consumer of data objects that are specified by an eventual GeoPose standard, you can know that your implementation conforms to this written standard or not. This implies that there needs to be a machine readable, automatable expression of the content of the standard. So we've gone from ideas, use cases, through natural language concepts, a logical model, to implementation targets, individual data objects in our case, which we define how to encode them in a particular form. We've picked JSON for now. And that those are encoded in such a way that you can test a data object you receive and determine whether it conforms or not. And if it conforms, then you know how to interpret the content. In GeoPose now, we've been through the process from the use cases to the implementation targets, the actual things that are going to show up in the standard to be standardized. And we're nearing the point where we have a coherent initial draft of the standard.
Can I ask you, so if we, sure, when we have this coherent draft, then we can publish that, right? And can get feedback
Yes.
from potential implementers like we have in our in Open Air Cloud with Open Spatial Computing Platform. We care mostly about one of the implementation targets.
Yes, so that's exactly the point where we say we have finished our first iteration and we're now able to let other people look at it and review it, comment on it, tell us what we've done wrong, tell us what's missing, tell us where it's too complicated, all that feedback. It's possible to also join in the cooking of this meal before it's finished, if you want, through OGC. So it's an open process and anyone can join.
Yeah, and great. I want to just mention one thing before we continue. When we came to OGC, we had more simplistic views on the standard. But as we have been working with other stakeholders from other like adjacent technology areas, we have developed this really robust logical model that can work with aerospace and construction engineering and a lot of other industries. So, and while still being able to have implementation targets that are ideal for AR, that are really simple and basic, like the basic GeoPose implementation target that I hope we'll be able to share quite soon with the wider world. So next on this panel, We got James Jackson, our really amazing CTO, who has been putting together some really awesome open source. Would you like to describe some of the generic or top-level architecture goals of the Open Spatial Computing Platform, and how we're going about to implement those?
Sure, thanks, Jan-Erik. So for the Open Spatial Compute Platform, one of our core goals is, of course, to develop open source reference implementations. So reference implementations around the GeoPose representation, ideally a GeoPose compliant localization protocol at some point. Spatial services protocols. So I'll touch more on what we've been doing in terms of spatial discovery, and ultimately evolving towards supporting a reality modeling protocol, as well as looking how behind the scenes data sharing and permissions need to be developed. But in terms of what we've got right now, from a spatial services discovery perspective, we use different terminologies for the space. Sometimes we say AR cloud, sometimes we say spatial web. When we think about an evolution to an open spatial web, one of the core aspects of this is search and discovery that Christine mentioned, right? And there are a couple aspects to that. Firstly, discovery of spatial services themselves in a given area. So for example, what GeoPose providers are available around me, right? So we have Augmented City and Immersal as examples here, right? Or maybe which reality services are available around me. We have Worlds here with us. That's one aspect. The other aspect is the discovery of spatial content or experiences. So that could, for example, be actual virtual 3D assets that have been anchored in the city. Now, in terms of what's really important from a user or a client perspective, there are two components. One is that we have a common interface or APIs to these discovery services. And the other is that we have a unified discovery experience. And that one's a bit more tricky. So what I mean by a unified experience is that we want to make sure that search or discovery is not fragmented such that what you find is dependent on the provider that you're connected to. So I'm not going to get into the technical details, but sort of at a high level, the way we achieve this is that for a given area, we have multiple spatial search providers in a decentralized architecture. There's a peer-to-peer relationship between them. And essentially, those providers are contributing to a common shared spatial index. So that same data will be discoverable by anyone regardless of which provider they're using. Now, this isn't just a vision. We've got working code. So you can take a look at our GitHub repos for the spatial service discovery and spatial content discovery. You can see the APIs have been defined, the spatial records have been defined, and we're actually running prototypes of this in some of the cloud platforms. And we've got clients that are starting to build applications, and we certainly welcome additional folks to join us in this effort.
There's actually a client open source project on our GitHub repo as well for running a connection to this platform from the web browser. So
yep, exactly.
Yeah. Yeah, and so the platform is being developed and designed, and we are super excited about the ideas and the concept. But we are this little minute group of spatial computing geeks, and it doesn't really matter in the end if we think it's great if it doesn't hit some sort of product market fit out there in the real world. I like to call it platform market fit. Is this stuff that we're thinking is a great idea, is it actually going to pan out if we try it out in the real world? And that is so crucial. And now, even though we are in this early phase of the design of the platform, we are actually taking these concepts out there in a city scale scenario in starting with 2 European cities. So first is Bari in Italy, and then is Helsinki in Finland. We really hope that these test beds, I think there are 3 main things that we want to do. We want to check if the platform works as intended on a technical level. And then by having a real world test bed, then we can start to rapidly iterate on the designs and see if when we're trying it out in the real world, if something doesn't work as well, we can adjust the designs of the platform and do that with short iterations. But most importantly, we want to check if people, local businesses, spatial computing companies, if they really if they get on board with this idea, if they think that this is a great experience, this is a great use case, this is a great case for my business, this is a great thing for my city, if we can validate that there's actually a potential that people will want to use this platform, this is what we really want to find out. So first, Vladimir, you were the one who really started this by in this summer you proposed that you could take on running a test bed in the whole city of Bari, where you mapped, did you say 100 square kilometers of that city is mapped already?
Yep.
For
Yes, it is about 100 square kilometers, and there are more than 5,000 AR objects already there with all the links between them and information about them. Yeah, so from the very beginning, our goal was to prove that everything works in a real big scale, because here the sizes matter. The size matters. One thing is to run everything in laboratory, covering like I don't know, 100 square meters or even 1,000 or 10,000 square meters. And completely another thing is to handle a really big array of data. So currently we have several terabytes, even operational data, and handling hundreds and even thousands of users simultaneously. So currently that's what we do. Well, I am really proud to say that we achieved these goals, and currently the platform really handles this amount of data and that amount of users. And what we are doing now, we are actively working with the local business community just to define the valid use cases, to make them to try the platform, to give feedback, and definitely we are working closely with James Jackson to improve on the technical part of the platform, on the interconnectivity, and we welcome also other providers of geospatial data just to try let's say intercommunication between different platforms, different providers.
yeah, so the testbed is intended to run for about a year in this initial phase. This is very early prototypical, where everything is moving pieces, and you have already up and running a spatial discovery service at your site, right?
Right. And we have plans to run spatial discovery services in other 9 cities we are currently working on.
Great. So move over to Mikko from Immersal and Helsinki. You were the first one who committed to supporting GeoPose for your visual positioning system, and you are the local coordinator, project manager for the testbed in Helsinki. Would you like to share some of your perspectives?
Yeah, thank you, Jan-Erik. So when the Open Air Cloud asked us if Immersal would like to create the testbed for Helsinki, it was quite easy to say yes, because we basically had all the building blocks implemented already. So just as Augmented City, we're like a company developing tools for mapping and localization, and we've been working on this for, I don't know, two and a half years or something. And last January or February, we released a new feature, GPS support in our maps. So all the maps can be GPS tagged, and also we can get the geopose from when we get the pose of the device. We also get the global WGS84 or ESEF coordinates, and those can be updated real time using the devices tracker like ARKit, ARCore. So we basically get a super accurate and fast geopose, 60 frames per second, and it's a lot faster and accurate than a satellite-based GPS, especially indoors. So when we had the feature, then we started to think internally what to do with it, and then we came up with the idea of mapping the center of Helsinki and doing a demo out of it. And that's what happened. I think it was in February and March when we actually had a deal with a local school, and we had 20 students in a row waiting to like kickstart the crowdsourcing of mapping. But then COVID-19 happened, the schools closed, and then eventually two of my colleagues, big respect to them, they did all the mapping together. So I think in maybe 16 hours, they mapped like 1 million square meters of the center. So like each of them about 8 hours. So it was a lot of walking in the freezing cold weather during the winter time. But the end result was actually pretty good, and we released like a demo video of it, and where you can see the center of Helsinki point cloud zooming out. And then this was also not just a nice demo, but it actually helped improve our product, because we were fine-tuning all the parameters of the map construction algorithms and localization algorithms, and we noticed that like both didn't work quite as good as is possible. So just tweaking the parameters, we could get really good like results, and both of map constructions and localizations. So nice internal demo, which also helped our product. So I'm happy about that. And then we also, while creating the maps, so it's not a one huge single map, it's maybe 120 smaller maps that are aligned next to each other. And most of this alignment actually happened automatically because the maps get their GPS position. So we compared them to a regular Google Maps 2D map, and we actually found out that they're pretty well aligned already. And then we developed some internal tools to manually correct the alignment, and we're able to create a matching point cloud map on top of the 2D map. And yeah, I'm not sure if it's localizable anymore because the weather conditions have changed a bit since winter, but we're definitely looking into crowdsourcing again and updating the maps and making it work. And so with the Open Spatial Computing Platform, I think it's when the API is ready, it's just a matter of like mapping the API to our like proprietary REST API to get everything to work. But as I said in the beginning, all the building blocks are ready.
Yeah, we're currently still working out details on the protocol for
Yes.
GeoPost services, and we had some meetings on that, and I would assume that we get to something that is quite usable within not too many weeks, and that is sort of like the early phase of the very first test beds where we are more or less learning how to do test beds. Later on, we might want to do many more test beds around the world. So in Germany, in America, in Norway. So we're having discussions all around the world. But one thing we saw here today, that we have two companies that are providing similar core services for spatial computing. And we want in the test beds to have them simultaneously available, so that in Perey you will be able to swap from one service provider to the other and see if the platform still works. If you register some content in the real world and you're using the Augmented City GeoPost service, you should be able to sort of click the button or have another user looking at the same content using another service provider. So for Helsinki, we will have both Immersal and Augmented City mapping and providing GeoPost services. For Perey, we will both have Augmented City and Immersal mapping and providing GeoPost services. And that is sort of
Jan-Erik?
Yeah.
I wanted to add to the goals of the spatial computing platform test beds that we also need a lot of content. This is having these services without having a lot of content registered through some type of directory kind of misses the point. The people who go to those test beds will not see anything or be able to experience anything. So we have a challenge that has been in existence for many, many years, and the test beds should help us to overcome, which is we're not encountering, with so little content today, we're not really encountering the situation that we'd like to simulate in the future. So we are looking to a variety of different partners in the test beds to contribute points of interest information, not just commercial information, but civic information around learning or museums, cultural heritage, and so forth. So it has to be diverse, and there has to be a lot of it.
And that's actually a good point, because cities like Perey and Helsinki are smart cities. They have smart city initiatives, and on the government level, they are collecting a lot of useful data, but it might be hard for smart city initiatives to make use of that data and to get it out to the public and get it out into commercial use cases or public service use cases. Now this platform is tailor-made more or less to bring that kind of spatial smart city data out to the different end users. So we're looking forward to collaborating with smart city initiatives as well.
Yes, that definitely makes sense. And we also have one partner company who might be doing a project in Helsinki using our map data. So they will create the content and we build the infrastructure, and we're not dealing with the content ourselves.
Yeah, and another aspect is that not only are we registering content, but we can register services in the area. So that might be public transportation information that are real time, and you can buy tickets through this kind of discovering it on the Spatial Discovery Service. But there could be more advanced spatial computing things that you can also register. So imagine something like Cloud XR from NVIDIA could be registered as available in the city. And there might be even like a payment option so that you could automatically trigger the purchase of a service that is available in your location. That could enable stuff like photorealistic renderings of planned building at one-to-one scale at your location. There are potential outside of the really like the core platform features. We cannot really develop everything, but we see this platform as sort of a interoperability layer that can hook everything together. The GeoPost connects you to the physical world with 6 degrees of freedom. You have the machine readable world available to all kinds of use cases. And then you have a seamless way to discover content and services at your location. So one thing that we will not be able to start with from the get-go, but is at the core of what Jason Fox is working on over at Worlds, is you call it reality as a service, we call it reality modeling language and the machine readable world. Would you like to give some of your thoughts on how you're seeing this future?
Yeah, I mean, I'll start with kind of the technological concepts around it and sensing. So the way I like to describe it or talk about it is, you know, reality as a platform or reality as a service. And what that means is it's not only the 3D map of the world, but it's intelligently observed insights into what's happening on top of the 3D map. And so a couple of good examples would be, you know, tracking people walking by. You know, it'd be useful to know in a spatial context where everybody is. You know, you don't need to know specifically who that person is, but you need to know that there's a person there occupying that space. And so that's kind of like the idea is, you know, how do we create methods for sensing things about reality using different types of sensor suites like video cameras. That's one we use today. IoT devices, even smell sensors. We actually have chemistry smell sensors that we're using in some cases. And we're doing it right now and generally kind of approaching it through a commercial point perspective, because that's, you know, enterprises have a lot of money to spend and they like to solve problems. And so, you know, we're doing things like tracking worker movement through a process, vehicle movement through a site, equipment location in a site, you know, and gaining those insights through these different sensor systems. And, you know, there's a lot of different things converging here. We've got spatial computing. You know, we need to have the 3D map as a reference, as the building block. And then we need to have an intelligent layer that accesses different sensors and then can tell you what the data means coming from the sensor in a computer readable, as you say, way, but also is intelligible to people and people that consume this. And so if you're able to do this and you can combine it all together and layer this intelligence on top of the 3D map, then you get this kind of comprehensive understanding of reality. And that's where I like to say the concept of reality modeling comes in, where you can have this almost like a stream of consciousness flowing through a computer system of all of the activity that's happening around you, and you know, where things are located, and to some degree what people are doing or what vehicles are doing, and what direction everything is moving in. So you get directional vectors, you get, you know, spatial proximity analysis is one thing we're doing. So how close are things together? You know, so that's the general idea. And, you know, eventually we'd like to get to the point where, you know, the platform is actually exporting through an API or a service. So this stream of consciousness I'm kind of referencing of reality models in your immediate vicinity.
Yeah, one thing we have been discussing is there might be a difference between something like the GeoPost service that you might have fairly sporadic. You get your GeoPost and maybe you can wait some 30 seconds before you have an update where you ask for it again so that you continue to stay in sync. But for a reality service, you might want to continuously stream updates. That might be in cases where you have like moving traffic, and then it's not just a request response classic server kind of thing, but it might be more like a socket server where you have multiple entities that are connected simultaneously and send data back and forth.
Yeah, I mean, it's, yeah, you would consume it. It's probably a little more akin to like a video stream. You know, you'd be watching it frame over frame like that. In fact, we do have the concept of frames in our system, and for lack of a better term, because I don't think we've coined a term yet, it's something like a reality frame. And so if you could think about observing reality at 30 frames per second through video, and then pulling out all of the intelligence, you know, detections through machine learning and other methods out of that video, and then encoding it into this just simplistic data format that other systems can consume. And that's what we're going for.
So this kind of technology gives an immense amount of new opportunities that were never possible before. So developers could start to rely on something entirely new for developing spatial computing applications. And that could help sort of the blind, it could save lives in traffic, it could make really convenient indoor, outdoor navigations that are already always up to date with what is happening in the real world. But at the same time, you're capturing reality in minute detail. And so then you really see this double-edged sword thing where this kind of data can be abused, or it can get in the hands of bad actors. You could potentially have a loss of privacy if the systems around these types of technologies allow for instance, central aggregation. So imagine some large tech company or government are connecting to all those different localities that are capturing reality in real time. If they are allowed to and able to always aggregate that at their will for no particular reason, they are sitting with a kind of power that we can be pretty sure will corrupt. So when OpenAI Cloud was founded, we also put out privacy manifesto for AI cloud solutions. And also previously you have heard from XRSI, one of our partners, about how we're working, how we're kind of trying to challenge how solve the challenges around privacy, security, and also making us GDPR compliant and being acceptable to governments, being acceptable to people. I think there's this aspect of having people trusting the platform before they really commit to using it at that level. Or maybe general people, they just get overruled. They think that, oh, this is convenient. They don't care about their privacy. They don't care about. But we think differently in OpenAI. We think that eventually people will care more and more about this, and our platform concept is we want to tackle this from the get-go. So we
Jan-Erik?
Yeah.
Yeah, I wanted to add that the test beds and the Open Spatial Computing Platform test beds provide an opportunity to test some of those sensitivities, as well as how to manage personal data. Some of the systems that can be implemented in a safe environment, in a trusting, well-managed environment like these test beds. But the spatial computing platform concept has to be highly scalable. And there's so much diversity in the culture. Different countries, different communities have different, the appropriateness of certain privacy concerns in a social network is different than in emergency responders. You need to be able to get the private information about the members of that household so you know that you're saving all of them in a fire.
Exactly.
It's such a, there is no one size fits all.
That is true. I think it's a great thing that
we actually hired an identity privacy expert out of the banking industry. Just, we haven't started developing anything specifically around identity yet, but we anticipate we might, and we want to make sure that we're doing it in a way that is safe for the people that are being, observed and are participating in our platform, the individuals. So I just wanted to add that.
If I can add to what you were saying, one of the things we might be able to do for like the base case of use of this technology is that we want the real-time kind of data to be transient and not aggregated in the default case. So normally when you access this reality server, you get what is happening right now, but you won't necessarily have the stuff that is going on in the public spaces. You won't have those long records of what happened in this place, because that's sort of an aggregate that could be abused. And also in the default case, the data is not sent to a central location. So it remains within a geo zone, within a part of a city or something like that. And it is only sort of in an emergency situation when first responders need to have access to that to save lives. Then there's a transparent way that this sort of edge firewall is breached for the purpose of saving lives. We are nearing the end of this panel discussion. I hope you have learned a lot, and I hope you feel inspired to check out the test beds and participate in the test beds. So the key people to contact for the first two test beds is Mikko and Vladimir. And as they are the organizers, but you can also reach out to Open Air Cloud. We are also open for discussing future test beds at other sites. The details of how those future test beds are going to be set up will be based on what we learn in the coming few weeks in the first two test beds. So we will provide more information on that on our websites. So keep an eye on what we're doing. This is going to be really exciting. We think we are creating a great alternative to the proprietary walled garden ecosystems that we see some glimpses of from some of the larger tech companies. We think this should be more like the open web that has been demonstrated to work well, and now we're trying to accomplish the same thing for spatial computing. We're doing the very first baby steps, but at city scale. So we couldn't be more excited, and we are looking forward to working with a lot of more partners in our test beds. So thank you everyone, and enjoy the rest of our symposium.
Thank you.
Thank you.
Yeah. Bye-bye.
Thank you. Bye.
you've been involved with a lot of standards work, both within OGC and also before OGC. What do you think about the GeoPost as a standards working group?
So was that addressed to me, Jan-Erik?
Yeah, it was.
Okay, yeah, because the first few words weren't there in my audio anyway. GeoPost is interesting because it's a smaller, more concrete, more well-defined standard. It's just where something is and which way it's pointed, location and orientation. So that's unusual. One of the problems in OGC standardization and other ISO standards is sometimes the group will try to engineer something while they're developing a standard, and that's not a smart idea. So it's nice and crisp.
Glad to hear that from really skilled and experienced person like yourself. So there was a question for James. Could you touch on how the Spatial Discovery Service uses a search area to provide some privacy to users as they search their local area?
Sure. Don't think I caught the question, but essentially in the Spatial Discovery Service, we have it partitioned by what we call Geo Zones. The Geo Zones are really intended to keep data local within, for example, a given city, right? So within that city, you may have some number of spatial providers that are synchronizing their data. But that particular concept is not specific around privacy. What we do, however, whenever you interact with the APIs, whether it's spatial content discovery or spatial service discovery, we've intentionally designed them in such a way that you are providing sort of like a geo hash of your location, as opposed to a very precise location that could identify exactly where you are. So we're actually using what's called a H3 hash from Uber, but it's a similar concept to a geo hash or S2 from Google or any number of sort of fuzzing mechanisms.
Yeah, it's actually, this is privacy by design, because you're not actually sending your accurate location to the service. So if the communication is somehow compromised, or if the service provider is compromised, then that data isn't available for abuse. So good point. Yeah.
Yeah. Well, I think the approach we generally take is let's provide the minimum amount of data that will get the job done. Right?
Exactly. And this is in compliance with the GDPR principles as well. So that is one way to check a box in GDPR, and we're happy that we're finding good ways to do that. There's 4 minutes and 55 seconds left of this session, but after this session, we can continue. Those who are up, we can continue with both a webinar session like this, where we can speak with each other like we're doing now, but we also have the air meet that I encourage you, those of you who have tickets, to join in the networking. This is a great opportunity to meet with some of the panelists, maybe some of the sponsors. I think I'll try to jump in there. I'm sitting at the table there, but I'm in this webinar, so I'm not really going to be responsive on that table until I go out of the webinar. But at least for the first half part of the session following this, I'll be in the webinar part. Then I'll see if I'll jump into the air meet after that again. Let me see. I'm going to close the second poll so we can have the results. And if I look at, does it show up? Okay, there's somebody asking for the AirMeet link. I'll see if it works. I'm not sure if it works like this, but I'll paste it into the webinar. So if you have access, you will be able to get in. I'm not sure. So 3 minutes. I'm going to start to prepare to get into the next webinar, and I'll be there. And you are free to either join there or you can go to AirMeet. Are there any? Yeah, well, let's look at the polls. What were the results for the design questions? We got 91% that it says it has the most important core concepts. So at least from this group of people, we have thumbs up. And there's one brave person who said it misses a couple of key components, and there are no percentage for the other ones. So would you like, if somebody is brave enough to join into the chat and tell us what is missing, that would be a great input. If it might not be the same person, but if some of you have the idea what might be missing that we should consider for this type of platform, please share that in the chat. Actually, I think I was mistaken about the last thing being a webinar option. Maybe you can confirm, Taylor. Maybe it's only AirMeet. So this is a question for Taylor. I don't know if Taylor heard. So if there's no webinar, then for sure I will be in the AirMeet. If there is a webinar, I'll join the webinar.
Yeah, I'm not seeing any comments about missing pieces, but we definitely encourage folks to reach out. Send us an anonymous email if you like.
Yeah, or you can use your full name. It's up to you. I encourage those who have ideas about what is missing. You can join in as members of OpenAir Cloud and be directly involved in the design works. That is a great way to contribute. But also just send us an email if that is sufficient. I'll be leaving here